There is one more useful variation on the two-sample t-test, which I've loaded here under Toolbox t-test two-sample. Now what we have here is data from January, February, March, on through December. The mean temperature in Ogden, Utah and Provo, Utah. Well, Provo's a little south of Salt Lake and at a little lower elevation. Ogden's a little north of Salt Lake and at a higher elevation. So the question is Ogden cooler than Provo? So let's just look at the data, and every month, see there's a difference. Every month, Ogden's mean temperature is lower than Provo's. You can check that through the list, and every month that holds. So you would expect that when I click calculate, I'm going to find a big difference. Well, I don't. There's no difference that we can detect. Well, the problem is that we're trying to detect a 2 or 3 degree Fahrenheit shift against a background of variation from somewhere in the mid-30s to somewhere in the 90s, and t-test can't detect that. But let's take a look at the same data. Whoops, not there. I've got the same data loaded over here. Here are my Ogden temperatures. Here are my Provo temperatures. And just for reference, I put in my months over here. Same data, and it doesn't matter which of these I designate as X and which is Y. That's arbitrary. Let's see what happens when we do that. I click calculate, and look what we get. Blue pointer far into the red. Yellow dot almost as far to the right as it can get. Meet the one assumption that I have to make. And it looks like we've got a really, really good predictive model out of the same data. So what's going on? How do we fix that in a t-test? Well, just a minute before we leave, let me just show you the scatter plot. Yeah, you just look at that and say there's a very high correlation. Provo temperature predicts Ogden temperature. They're highly correlated. Yet somehow the t-test is failing us. Well, let's go back over to t-test, and instead of two sample, let's do paired, because these are occurring in natural pairs. These are both January data. These are both February data. And the classic example that's given over and over again is suppose that you want to check the durability of material in shoes for boys. Well, if you put some boys in the new material and some in the old, well, some kids aren't very active and other kids are out playing basketball on the concrete and the shoes don't last very long. So you could use this, make a left foot out of one material and a right foot out of the other. Then you could run the paired t-test. Now watch what happens here. Bingo! No doubt about it. The blue needle is buried. We've got a very significant difference between the two, because what we've done is we've washed out the month-to-month variation. The trick is, if you look down here at the behavior chart down here, what it's doing is taking the difference between Ogden and Provo and then testing that difference with a one-sample t-test. And that works very well. So what we're seeing here is the typical about 3-degree difference between the two cities, and a very easily detectable difference when we've got data occurring in natural pairs this way. That's a really good tool.